Hey guys, so today I'm gonna talk about a huge number, a number that's probably much bigger than a Google. It's called a Boogol. So how big is a Boogol? So Google equals 10 to the 100 equals 10 arrow 100 equals curly bracket 10 comma 100 close curly bracket in BEF. That equals Bowers exploding array function. So Boogol is a prefix of by and Google. So Googleplex equals 10 to the power 10 to the power 100. That equals 10 arrow 100. That equals curly bracket 10 comma curly bracket 10 comma 100 close curly bracket. Giggle equals 10 double R 100. That equals 10 to the power 10 to the power 10 to the power. There are 100 tens high here. That's a really big number. That equals curly bracket 10 comma 100 comma 2 close curly bracket. Gigaplex equals 10 double arrow 10 double arrow 100. So this number is 10 to the power 10 to the power. There are gigo tens high, and then that equals curly bracket 10 comma curly bracket 10 comma 100 comma 2 close curly bracket comma 2 close curly bracket. That these numbers are very huge number. So gaggle equals 10 triple arrow 100. That equals 10 double arrow 10 double arrow 10 double arrow. There are 100 tens here, and then equals curly bracket 10 comma 100 comma 3 curly bracket close curly bracket. This is already bigger than 3 triple arrow 3, which is equals to 3 double arrow 3, and that equals 3 to the power 3 to the power 3 to the power 3. There are 7.6 trillion threes here. So gaggle starting from a power tower, it looks something like this. 10, we start at 10, and then there are 10 tens here high in the tower, and then the next later the number of the number of tens over here in this power tower is determined by this number. Yeah, the number of here of tens is the number of this huge number, and then the fourth layer up, the next above it, next to it, is the number of tens is determined of this number. So if you keep going doing that for 100 times, there are 100 levels times, and this final level, which is a very tall power tower of tens. So Gigo equals 10 4 arrow 100. That equals 10 triple out 10 triple out 10 triple out 10. There are 100 tens here. So this number is bigger than 3 4 arrow 3, which is equals G1. So that equals curly bracket 10 comma 100 curly bracket 4 close curly bracket. So that's this number is Googol. So this number is a very big number already. And this number 3 4 out 3 equals 3 triple out 3 of 3 triple out 3, that equals 3 double out 3 double out 3. There are 3 triple out 3 3, so that's how it looks, 3, and then 3 to the power 3 to the power 3, and then the next layer, the number of this number is 7.6 trillion threes here, and then the same thing as this thing repeated 3 triple out 3 threes. So this is a very big number already, and this number is way bigger than this now. Now 3 4 out 3, 10 4 arrow 10. Of course, the power tower of 10 of this number, the power tower it seems kind of messy. It looks something like this. So we start here at 10, and then here 10, and then this layer is 10 of 10s, and then the number of here is determined by this huge number of 10s here, and then here the number of 10s here determined by this huge number, and then there are 10 layers here. We are all over here in this little thing over here. So this is a huge number, and then 10 we follow the same here, the pattern here. So this this whole thing, this huge number, is the number of layers here. So, and then the third, maybe I will call it the third secondary layer or huge layer, is the number of layers next to below this is the number of this huge number. So we keep going this a lot, and then we arrive here, and how many times? 100 times. So here the number of this is a very huge number, and then this long one is very, very long. This is unimaginably big. So this is how big is Googol in 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 forms of a power tower. So this is kind of messy. It's kind of mind-boggling. It's kind of very hard to it's kind of very difficult to know this. So now, instead of now adding every arrow, because if you add every arrow to a number, it 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 kind of it kind of blow things beyond belief. So it kind of like it kind of makes a bigger powerful number. So every arrow you had, it'll make a bigger number. So now here, how many arrows you have? This number is called a Boogol. So that equals 10. Arrow, arrow, da da da, arrow, arrow, 10. There are 100 arrows here between the two tens. So that equals, it could be written as equals as 10 curly bracket 100 close curly bracket 10 in BEAF, or 10. It could also be written as this way too. And this one is written by is written like in the same way as written in as like this, but here is only determine the number of arrows. So in BF it stands for Bowers exploring array function. So here 10 curly bracket 100 curly bracket close curly bracket 10. This number here in the middle determines the number of arrows. So and also it could also be written as this number 10 close square close bracket 0 comma 1 close bracket 100. That is written in usernames 5243's array notation. So this is also a very powerful notation above up arrows. So this number is written as this in BEAF. So curly bracket 10 comma 1 10 comma 100 close curly bracket. Yeah, this number is how big is Boogol. This Boogol is a very huge number. It is much bigger than 3 4 out of 3, but still smaller than 3 G1 arrow 3. So that equals 3 G1 3 equals 3 arrow 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 3. There are G1 arrows. That equals 3 curly bracket 3 4 arrow 3 curly bracket 3. With 3 4 arrow 3 is a very huge number, and the number of arrows here is way much bigger than 3 4 out for 3, and also it's a very huge number now. So Boogol, this is how big is Boogol. Boogol is a very huge number that is much above level than a Googolplex and a Google. Boogol is much bigger than most normal Google numbers it could be added. So of course this number is still smaller than this number G2, which is called G2. So there you go. Boogol is still a very big number. Of course, you cannot write all the digits down, because it will it will be bigger than the observable universe if you write it on a piece of paper. So, thanks for watching. Have a nice day.